Hello everyone, today we will discuss proton NMR. Proton NMR. First of all, you should know which molecule is proton NMR active and which is not NMR active. So how can you identify that? First of all, if you are new on my channel, so please like, share, subscribe my channel. Now let's start today's topic, that is proton NMR. First of all, you should know how to identify that this molecule is NMR active or not. Nuclei have some charge, have some charge and non-zero spin number. Spin number. It means that molecule will be NMR active. So on the basis of nuclei, we can identify that the molecule will be NMR active or inactive. Nuclei. It's divided into two categories. The first will be magnetic, that is I is not equal to 0. It means I gives the some number, it is have some values, spin number, and here is come under the non-magnetic in which I is equal to 0. The spin number value will be 0. These will be NMR active and these will be NMR inactive. Now, how to identify the number one? If mass number is not divisible by 4, then it will be NMR active. For example, proton C13 and 14. Here the mass of nitrogen is 14 and which is not divisible by 4. Here the mass of carbon is 13 which is not divisible by 4. Here proton mass will be 1 and is not divisible by 4. It means all of threes are NMR active. Where if mass number is divisible by 4, it means NMR inactive. For example, C12, O16, silicon 28. The mass number is 12 which is divisible by 4, mass number is 16 which is divisible by 4, and the mass number is 28 which is also again divisible by 4. It means these are NMR inactive. Now further, let's discuss with the NMR active. If we study the proton NMR or C13 NMR, we should always consider the active molecule, not an inactive molecule. So let's continue with the active NMR molecules. So in further, NMR active is further divided into two categories. The number one is the non-quadrupole. Non-quadrupolar, and the second one is quadrupolar. In non-quadrupolar, I is equal to half. In non-quadrupolar, I is greater than half. The non-quadrupolar gives the sharp signal, or I can say that which have I is equal to half, they are give sharp signal, where in the another, when I is greater than half, they give the broad signal. For example, of non-quadrupole, that is proton, C13, F19, P31, and 15. All of these shows the sharp signal. Here in non-quadrupole, which shows the broad signal with eyes greater than half, that is D, that is deuterium, I is equal to 1, and 14, here I is also 1, is greater than half. No? B11, which is again I is equal to 3 by 2. Now, on further, let's continue non-quadrupolar. Non-quadrupolar. These are further divided into two categories. The first one will be the concentrated nuclei, and the second will be the dilute nuclei. Dilute nuclei. In concentrated nuclei, example, that is proton 1, F19, P31. These are the nuclei which shows the spectra early, faster. And in the dilute nuclei, that is for example C13, N15, whose abundance will be the less, here the abundance of the proton F19, P31 all shows the abundance around 100%, but in dilute nuclei the abundance will be the abundance of the C13 will be 1.1, and the in N15 will be 0.37%. The abundance will be the less, so it takes the more time to give the spectra, and it give the spectra in the less time. Thank you.